Okay, now I can go from current slide. All right, there are just a couple of announcements to make, I guess. Number one, last Friday was a very quiet day in the office, so I got a lot of grading caught up. Of course, I had some interruptions and some things had to be taken care of, but by and large, I got a lot of grading. So the stack is not nearly as big as it was last week, which is good. All your grading is done. And as I was telling my last class, yesterday being such a rainy day and stuff, my day off, I was able to get more grading done until my red ink pen ran out, and I went all over the house and could not find another red ink pen. So, well, not all over the house, but every place I could think of to look, and I couldn't find one. So I stopped grading and started putting grades in on Blackboard. I was telling Dawson that I think I must have just skipped over because I had grading to do a little bit in the pages here. I had some in the next 2 pages, some in the last 2 pages, but I didn't have any grading here, so when I was putting in grades, I just completely skipped your page. So I didn't get your grades updated. I thought I had, but evidently not, because the other student said, the last class said I didn't, and that's what I think must have happened. So, knock on wood, maybe I'll get them in this afternoon. I already have at least one student coming by for advising, so that shoots a hole in part of my office hours, but that's what I'm here for. Okay, so as soon as I can, I'll get your grades out there on Blackboard. So there's that. Number 2, another sort of good news, bad news situation, folks. The good news is next week is Thanksgiving week, which I think comes a little early this year. I think usually it's always the 4th Thursday, but the 4th Thursday's earlier in the month than it usually is. So the bad news is there's no classes at all next week. I get over it. We have professional meetings Monday, Tuesday, and Wednesday, so we are going to be at work, hard at work, I guarantee you. But y'all are going to be just kicking back and eating turkey. You know, no, you're going to be at work too. Huh? Okay, good for you. Someone's got to pay my Social Security, so keep getting raises, folks. Okay. All right. So anyway, there will be no class next week. So we'll have class today and Thursday, then an entire week off, and then we come back the following week and pick up and go from there. Okay. Can't think if there's any other announcements. So, and by the way, Dawson, if you can find an example in the text similar to what you're asking, I'll be glad to do that. He had a question on the test before class, and if you can find anything like that, I'll be glad to answer it. Okay, we are. Okay. Oh yeah. Okay. I was trying to say, why are we on example 5 when the slide set is on example 3? And then I recall they don't do. They did the easy one and then didn't do the next 2. Say again? This is 6.1. Yeah, 6.1. Page 403. Just the upper part of just above the middle part of the page. Okay, example 5. And I think we started talking about it, but didn't quite get there. Okay, so let me get my pen out. Any questions on anything we've covered so far, including that last test? Are there any questions on that? None? Okay. If you find one like the one you're asking about, I'll be glad to work it. Okay. All right. Find 2 triangles. They tell you, find 2 triangles for which A equals 12 meters Okay? B is equal to 31 meters. Okay? And the angle A is 60 degrees. All right. Now, let's think, sort of image this a little bit before we get going. A is 60 degrees. That's a pretty steep angle here, right? Okay? Pretty steep angle. The side over here, A is 12 meters. Okay? Your B, which is usually the side that leads up to that, is 31 meters. And that's a pretty long ways up here, but A being 12 meters, that hardly seems like it's going to fit. But maybe, I mean, the way they express it, it needs to fit. What that tells me now, obviously, is that angle A over here has to be a very small angle. Angle B over here has to be a very large angle. That's what it tells me. Because it's a lot larger than 60. Well, if it's going to be a lot larger than 60, it can't be any larger than 120, right? That would max out. So it must be a pretty good sized angle. I'm guessing obtuse. Okay. Because angle B's got to be larger than angle A, and angle A is already 60. So angle B has got to be a pretty good sized angle.
Angle A is 20.5.
Oh, I copied the wrong thing. I was going to say, how can that be? Yeah, just checking on the bulbs. Okay. I was going to say, I don't think this is at all possible, and you're absolutely right. I copied down, I don't know where I got 60. Oh, I see. I was doing the checkpoint above the problem. A is 20.50 degrees. Because I was going to say, I don't think this can work. 20.50 degrees. That makes a lot more sense. Because obviously angle A is a pretty small angle. And it is, okay? B is a lot bigger angle, so obviously angle B is much bigger. But you see, it can be still be acute and be bigger than A, okay? Significantly larger than A. So yeah, this one makes sense. The other one wouldn't have worked at all, okay? Now they go through and do that mess with the H equal B sine A, which of course we did, and that was before Jake got here, but we couldn't get finished before he did, so Jake's here. Hope I put you in the right place. Yes. All right. So we need to solve this situation. Now, with this one, with angle A being a small angle here, B being a long side, and little a being a short side over here, you can almost visualize that it could go that way or this way. And indeed, that's what it is. When it goes this way, this will be an obtuse angle. When it goes that way, it has to be still a fairly large acute angle, but just significantly larger than 20.50, which is quite possible. Okay. Now, they start with the H is B sine A. You don't have to do that, but you can. So if someone can do that real quickly, make sure you're in degree mode and do 31 times the sine of 20.50. 20.5 will work. And frankly, I usually don't do this. They do, and go back to that ambiguous case thing that has all those different conditions on it. It's just way too much to remember, and frankly, too much to fiddle with. So I usually just do the problem and see how it comes out. What do you get?
10.85.
10.85. So that's going to be the height. Okay? The height here from the end of B to the parallel down here, to the horizontal down here, that's 10.5. Okay? So you see A is 12. It could be over there or it could be over here. Either one. So this will be a two-triangle case. So that is worthwhile to do. And you can see that will definitely work. Okay? But I usually don't do this. I just proceed. So how would you start this? What would be your first step to solving and finding the two triangles that this may work?
Find angle B.
Okay, how do you do that? Oh, Andrea and Allison. Okay, good deal. Good, much better than my last class. In my last class, barely half of them were there, if half of them were there. Doing well, way to go. So how do you find angle B?
12 over sine of 20.
Okay, what rule are you using? Law. Law of sines. 12 is to the sine of 20.50 degrees is 31 over the sine of B. Now, remember we said this could be a two-triangle case, so you're going to get one answer here for B, but then you've got to see if that also represents another angle. So what do we get here if we do the math? Okay, the sine of B would be equal to the product of these two, 31 times the sine of 20.50 degrees, it's a pretty ugly 5, divided by 12. And you got what? 0.9? 9905 or 905? 905. Okay. I would leave all that number on my screen if you can for a moment. But how do you determine what B is? That's what the sine of B is. What is capital B? Okay, so with all that number on there, just hit a inverse sine key, and what do you get?
64.78.
B is 54.78. Is that what you said? 64.78. I can't write today, so let me erase that. 64.78. Is that what you said?
Yeah.
Okay. 64.78 degrees. Now, that's one possibility. Now, as we said, it has to be an angle bigger than this, and certainly that is. Okay? But, okay, 64.78 would be in the first quadrant. There is a corresponding angle in the second quadrant that it could be as well. And what would that be? Second? Okay, yeah, let's not do it that way. That may get you there, okay? But no, it won't, okay? Here's what you do. I always like drawing pictures, even though I don't draw very well. Okay. Okay, it's not that funny. Okay. Here's this one. 64 something, I know the degrees. The other one's going to be this same angle. This is your 64.78 degrees, right? Well, on the other side, that must be your reference angle, 64.78 degrees. But the actual angle you're interested in, let me do a different color. Someone give me a color. Blue? Huh? okay, then this is the angle you're interested in. Now, what's its relationship to the 64.78?
Complementary.
Not complementary.
Supplement.
Supplementary, right. Which means? Anybody? How would you get the blue line? Huh? Yeah, subtract the 64.78 from 180. So if you have that up there still, just subtract that from 180 and see what you get. All right. Or B could be 115.22 degrees. That would still be a perfectly good angle because you see, obviously, these two added together leave you room to 180 degrees. But these two added together, you still have room before you get to your 180 degrees, okay, for another angle in there. So this is a two-angle case here. So you could get two triangles out of this one, okay? Now, that figure up there was good for what it was worth, but it's no good for what we're trying to solve. So I'm going to erase this for now and then put in the ones that really represent our problem better. Okay? So, here's a horizontal. Oh, let me go back to black. Oh, that's the wrong one. That's the one. Okay. Obviously, my drawing, well, it didn't go back. Okay. There, I got a little more horizontal line that time. Still not great. Okay. And we know this angle here is a fairly small angle, 20.50 degrees. Okay? Now, and this is side B. And side B is 31 meters. Okay? This is angle A here. And somewhere over here, we have angle B, or angle B. Okay? The first B is this angle here is 64.78 degrees, which probably isn't like what I've drawn here, but could be somewhere close to it. Whereas this angle B is your 115.22 degrees. Okay? Now, so there are your two cases for your B, and by the way, the side A over here, same A, what am I trying to do? Is either 12 meters here, or it's 12 meters here. Side A still has to be 12 meters. I know that's sort of small and crowded, but is that making sense? All right, so we have the black triangle, which is an acute triangle, or the blue triangle, which is going to be an obtuse triangle. Okay. So, where do we go next? We found our B, but we wound up with two B's. Okay, or not two B's. Okay. So what do we do next? Okay, find angle C. And we actually have two angle C's then, don't we? Okay, here's our angle C up here, and that could be the black angle C, or it could be our blue angle C? Okay. All right. And this is really going to get crowded. What would be our black angle C? That's the one you chose to do, wasn't it? Add these two together and you get 85.28. Right? I'm doing it in my head, so check me. And Jalen's here. Near perfect attendance today. We're missing Gavin and Josh. Okay. So these two added together, if my math is right, would be 85.28 degrees. And if you subtract that from 180, you get 94.72. Is that right? So this angle up here, my black angle C, is 94.72 degrees. Y'all be doing your math and see if I'm getting it right. Okay, good. Thanks. Okay. Okay. Or my blue angle C would be 115 plus 22 plus 2050 would be 135.72, and subtract that from 180, and you would get 44.28. Is that right? So my blue angle C would be 44.28 degrees. Is that right? I may have, that doesn't seem small enough. Yeah, it may be. Is that right?
Divided by 2.
I'm sorry?
You just divided by 2.
Okay, it shouldn't be.
Just on half of it, and that's the blue.
No. You don't do dividing by 2. It has to add to 180. Okay? We got this one plus this one. That gave us 135.72. Subtract that from 180. That's how you get that. It's not ever, I mean, it could be half if those were 30s, 60s, and 30s. That would work. But anything else is probably not going to be half. So, did you get 44.28 when you did it? I don't know. I'm just looking at mine. And you see that unless I've made some dumb math error, I think that's right.
Yeah.
It is? Okay. All right. So there are 2 possibilities for C. The Black Sea is in south of Russia, or the Blue Sea is 44, it's deep by the way, 0.28 degrees, and the Black Sea would be 94.72. Is that right? All right. All right, we have started solving it. We found 2 possibilities for B, 2 possibilities for C. Okay? We've got side B is fixed. That was given as 31. So that doesn't have any possibilities. But what other thing has 2 possibilities?
Side C.
Side C. Okay? Let's see, which color do I have here? Black. So either this is, whoops, that should be a small letter C, it by definition is, or the C could be this C. Okay? Either from A to blue B or A to black B. Okay? That is the length of C. And how do we get that? Which one you want to go for first?
Side close to angle A.
Okay, we're going to use angle A and side A. For sure we're going to use that. But which one you want to do, the blue or the black? That's what I was asking. I don't care. Black, okay. Let me get back to black then. Okay. And then we would say that 12, that's side A, is to the sine of 20.50, law of sines here, as, what would be the rest of it? Little c, black c over 94.72 degrees. Okay? And you do the math there. Little c would then be, cross multiply here, 12 times the sine of 94.72 degrees over the sine of 20.50 degrees. And what would you find that to be? This will be the long C, the big C, not big C, not capital C, but the longer little c. It should be the longer than 12 and longer than 31, because your angle there is larger than 20 and larger than 65. Larger than 21 and larger than 65. What you get that C to be? 34. Let's just say 34 meters. See, the angles they gave us to 4 digits, so I don't mind putting 4 digits to those, but the lengths are only 2 digits, and really we shouldn't do anything more than 2, but they gave the angles in 4, so I'll do that. But let's leave that as approximately 34 meters, which is longer than B and certainly longer than A. Okay? Now, let's do the deep blue sea. The other little c, what would that be? I'm going to do it over here so I don't have to write it again. C over what? C over 44.28 degrees. I'm running out of room. Okay. Now we'll do that cross multiplication here, and you get C is equal to 12 times the sine of 44.28 degrees, and that's divided by the sine of 20.50 degrees. And I'm sorry, my pen is very slow. When you get this much writing on the screen, the pen really slows down, so I didn't quite get that looking good. And what would that be, approximately? That's a 20.50 down there. This should be in between 12 and 31,
because 44.28 is in between 20.50 and
23.12.
say that one more time.
23.12.
Let's call it 24 meters. Okay, my pen is really slow. About 24 meters. Okay. Yeah, and that's in between 31 and 12. Exactly. So let's see what we got. Either they called them, rather than blue and black, they called B1 was 64.78, which made B2 115.22. Okay? And that made C, they didn't carry through and do this, but it should have been C1 94.72, which is correct. And then later C2 is 44.28, which is correct. And it made little c1 34 meters approximately, and little c2 23.92, which is 24 meters. Very good. So you wind up with two possible angles there, triangles there, depending on whether actually in this problem C is obtuse and B acute, or C is acute and B is obtuse. Now they won't always, well, let's see, maybe they will always be that way on these two triangle solutions. I guess I know one of them is either going to be acute or obtuse, and it may be the other one's got to be that too. Yeah, because it's got to be on one side of, I think it might. Can't swear to it. But anyway, we did it. We solved it. All right, any questions on that? So watch out, folks, for that situation when you have side-side angle, okay, you may have no solutions, one solution, and there's two different situations you could get one solution, or you may have two solutions. And you have to determine which of those is going to be the case. The no solution is usually pretty easy to pick up. When you try to do your law of signs, you'll get an impossible answer, and you'll say, no solution. Okay. It's the missing the two solution case when one solution is possible. You might not realize there is a second solution. Okay. So let's go to the next to last topic in the section. Okay, let's get through all these. Area of an oblique triangle. Remember what is an oblique triangle? Oh, it was a long time ago. What is an oblique triangle? It's basically one that's not something else. It's not a right triangle. If it's not a right triangle, it's called an oblique triangle. Okay? Now, a right triangle is easy to find the area, right? Right? 1/2 the base times the height. Here's the base, there's the height. Okay? You got everything you need right there. With an oblique triangle, you can't do that. It's 1/2 the base times the height, but the base you know, but the height is something that's not quite as obvious. Okay? Or it kind of is. Okay? The procedure used to prove the law of sines leads to a simple formula for the area of an oblique triangle. Because how do we find the law of sines? We determine the height. And the height was b times the sine of a. Right? b times the sine of a was h. Because that does make a right triangle, and then the sine of angle A is the opposite of the hypotenuse, which is h over b. So b times the sine of a is this. So, since you know that's the h, is the base 1/2 the base times b sine a. Well, the base is c, okay? So 1/2 bc
times the sine of A. That'll give it to you every time. Okay? Even if it's an obtuse triangle, which of course would be oblique as well. That gives you the formula. So here it is. Consequently, the area of each triangle is 1/2 the base times the height. The base was C, the way we drew it, and the height was B times sine A. So the area of any triangle, if you know two sides and an angle, then it's the angle in between those two sides, then it's 1/2 BC times the sine of A. But if you could have done it that way, you could have chosen any other side as the base and then done the same thing. So it could be 1/2 AB times the sine of C, 1/2 AC times the sine of B, or 1/2 BC times the sine of A. Any two sides you know, and the angle in between those, doesn't matter what you name them, it's going to be 1/2 the product of those times the sine of the angle in between. Pretty simple formula. Okay? So here's the restatement of that very same thing. The area of any triangle is 1/2 the product of the lengths of two sides times the sine of the angle of their included angle. If you know the angle between those two sides, then you know it's here. Okay? You know the length of two sides and the angle in between. Length of two sides, angle in between. Two sides, angle in between. You know the area of the triangle. Note that when angle A is 90 degrees, say this is 90, why they didn't say C? I would have said C because that would have fit the way we did it. The formula is given for a right triangle, which is 1/2 base times height. Because the sine of 90 is, sine of 90 degrees is 1. Exactly. So that would be 1/2 the base times the height. Exactly. And then you can do either B or C or B. Being 90 degrees, it still works. Okay. So here's example 6, bottom of page 404. Find the area of a triangular lot having two sides of length 90 meters. Oh, let's go back to black. 90 meters. And, whoa, I didn't leave enough, did I? 52 meters. And this angle in here is 102 degrees. There's a triangular lot. What would be the area of that lot? What's the area of the lot? 1/2. Yes, 90 times 52, 90 meters times 52 meters times the, okay. Now, you can do this any way you want to. I find it easier to do half of 52, which would be 26. And 90 times 26 would be 0, 54, 18 and 5, 23 times the sine of 102. Y'all have to do the rest of that because I can't do sine of 102 in my head. Anybody? 2,289 what? Square meters. Perfectly. Perfect. Okay. Let's see what they got. 2289 approximately. 2289 square meters. Very good. All right. There is a checkpoint. I highly recommend you do the checkpoint as soon as you can outside of class. Oh, and since this
is one they've done. Let's see how they did it. I think it'll be very similar to what we did. All right, consider A of 90 meters, okay, B of 52 meters, and angle C of 102 degrees is shown here. Obviously, mine exaggerated that 102, but the area of base of the triangle is 1/2 AB times sine C, which is 1/2 90 times 52 times sine of 102, which is about 2289 square meters. All right, then there's an application problem, and they love these on the water, don't they? Okay, here comes another one, I think. Yep, the course for a boat race starts at point A, that's up here at the top, proceeds in the direction south, but 52 west, so there's your angle. You look to the south, do 52 degrees to the west from there. There it is, and you go to point B. Then in direction south 40 east, so again look to the south and you do 40 degrees to the east to point C, and then you go back to A due north, and that's the only length they give you there of 8 kilometers. Directly south of point A. Okay. Approximate the total distance of the race course. All right. Well, this is a mess, isn't it? Okay. What's messy about it? Okay, you're given one leg of the race course. And that appears, by their drawing, to be the longest leg, though you can't swear to it. They may have intentionally done it poorly. But I think in just a very short time you see it is the longest side. They gave you one angle that's in the triangle, and then one angle that's outside the triangle. So that's a pain in the neck, isn't it? How can you solve this? Yeah, you need to find the other two sides, but without this angle, this angle does you no good for that angle. Here is, to use law of sines, you have one side given, you need the opposite angle, but we don't know the opposite angle. So are we sunk before we even start the race? Why not? There's a little bit of geometry here, and it may have been a long time since you had it, but it makes perfect sense. If you have two parallel lines, which this one south here and this is south here, those are parallel, right? And you have this angle, this line that crosses them, then what they call alternate interior angles are equal. Here's a 40, that means that has to be a 40. Does that make sense? Okay. So sure enough, we do know angle C because that's the same as the angle B we were given up there. So angle C is also going to be 40 degrees. And once we know angle C, what do we also know? Angle B. How do we get that? Say again?
180 degrees minus 52 degrees minus 40.
Yes, okay, and 52 and 40 are 92, aren't they? If you add those together and subtract that, and you get 88 degrees. All right, so angle B over here is 88 degrees. That does it for us, okay? Where can we go from here? where can we go from there?
Use law of signs.
The law of sines, and how would you use that here?
Do
8 kilometers over
88,
sine of 88 degrees, lots of 8s there, is the same as what? Little a, which I'm going to assume is this length down here, right? The side opposite angle A over sine of 52 degrees. Okay, which would make little a equal, cross multiply here, 8 times the sine of 52 degrees divided by sine of 88. What would that give you?
6.307.
Okay, say that again.
6.307.
307 kilometers. Okay, now I'm going to let you get away with having more digits there than we probably should have, because if we rounded everything, this would only be 6, and that might not be too far off, but let's see. We won't use all 4 digits. We won't use any more than 2. 6.3 is probably what we'll wind up using. So, okay, let's go from there. What else can you do? That gives you A. I'm going to say approximately 6.3 kilometers. What else do we need? Okay, you need side C, little c over here. And how do we get that?
8 over sine of 88.
Okay, so again, you start off with 8 over sine of 88. Just hope you got the 88 right, because otherwise you're messing up everything else. It's equal to c over what? Sine of 40 degrees. You know that was right because it was alternate interior angles. So your c is equal to 8 times the sine of 40 degrees divided by the sine of 88 degrees. What does that give you for little c?
5.145.
Okay, kilometers. So if we let that be 5.1, okay, and 6.3, and 8, because it asks for the length of the course, total distance of the race course. That would be 11.4, and 8 would be about 19.4. That's probably close enough for government work. They say 4.6. They carried the digits a little bit further. Actually, they probably are no more precise than we are, because they rounded that to a 5.15, and that would be a 5.31. They did both round-ups, significant round-ups too, or at least that one over there. And so I'm guessing their answer is a bit too long. Ours is probably closer to what the real situation is, because we didn't use that many digits. Yep, they got 19.46. There is a checkpoint following. Any questions on that one? Let's see how they did it, if they did anything differently from what we did. if there are no questions. Okay, because lines BD and AC were parallel, it follows that the angle BCA is equal to the angle CBD. Okay? Because these two lines are parallel, this one and that one, the angle here, BCA, is the same as the CBD, however they said that. BCA, yeah, is equal to CBD. CBD, yeah. Those two are equal. So we know that one's 40 degrees, and that the other was 52 that was given. So you add those two. That's what's given in the triangle after you make that revelation that angle C is the same as the angle that was underneath B. Then, to measure the angle B, you just take the difference. Add the other two and subtract from 180, and that gives you 88 degrees. And then the law of sines, they list all the possibilities there. But they should have put a B of 8. If you're going to substitute them all. Okay? And so A would be 8 over sine 88 times sine of 52, which would be about 6.31. And I rounded to 6.3. And C was equal to 8 over 88 times the sine of 40. And that's also about 5.15. And then you add those three together, and you get 9.46 kilometers. Okay, any questions on that? I think that's the end of the section. Yes, it is. So let's us turn to the next page. And we have very few vocabulary, only 4 vocabulary questions here. Let's do them. And blank triangle is a triangle that has no right angle. Oblique. Number 2. For triangle ABC, the law of sines is A over sine A is equal to something, which is the same as C over sine C. They got it. Number 3. 2 blanks and 1 blank determine a unique triangle.
2 sides and 1 angle?
Not necessarily. Remember, that could lead to an ambiguous case. That wouldn't be unique. 2 angles on one side will always give you a triangle. Okay? And here's why. If you know 2 angles, you know the third angle. And you can always set up the law of sines with that and with no ambiguity at all. Number 4. The area of an oblique triangle, ABC, is 1/2 BC sine A, which is the same as 1/2 AB sine C, which is the same as
1/2 AC sine B.
Got it. 1/2 AC sine B. All right. Homework exercises here would include do either 5 or 7 or both. They're both at Calc Chat. Then do any of the odds 9 through 21. They're all at Calc Chat. 11's at Calc View. Do any of the odds 23 to 31. They're all at Calc Chat. 29's at Calc View. Do any of either 33 or 35. They're both at Calc Chat. 33's at Calc View. Do any of the odds 37 to 43. They're all at Calc Chat. 37's at Calc View. Then do any of the odds 45 through 53. They should all be at Calc Chat, and I don't think any of them are at Calc View. Then you have 2 true false, 55 and or 57. They should be at Calc Chat. 59 is an error analysis, which they tell you up front it's wrong. You figure out what's wrong with it. And then 61 you can think about doing if you want to. It's up to you. It's interesting thing to think of. All right. So that finishes 6.1 law of sines. So anyone guess where we're going next? 6.2, which is a good guess, which is law of cosines, which is another good guess. The law of cosines is very different from the law of sines. A little more involved with it, but also it smacks of familiarity with something we've already done. Okay? So in some senses, the law of sines is easy to remember. The law of cosines, even though it's a little more complicated in some sense, it's also should be fairly easy to remember. Our objectives here, remember we had something like 5 or 6 cases, and law of sines worked on 3 of them. Law of cosines works on 2. So I think we had 5 cases. So you can use the law of sines to solve oblique triangles side, 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 or side, angle, side. Okay? Now the difference here in side, angle, side, and side, side, angle is the fact this angle is in between those 2 sides. The other, the 2 sides were adjacent, but the angle was not in between them. Okay? So this one you can use law of cosines, the other law of sines if it works. And then we'll also use the law of cosines to model and solve some real life problems, and then come up with yet another area formula to find the area of the triangle. Heron's formula. Back when I was in school, I remember for some reason they called it Hero's formula. I think sometime since then, which was a long time ago, they found out the guy's name wasn't Hero, but was Heron. I don't know who had left off an N, but anyway, it's now Heron's formula. Here's the introduction. 2 cases remain in the list of conditions we had back at the beginning of law of sines. And these are for an oblique triangle. If you know 3 sides and no angle whatsoever, you can still define that triangle, or 2 sides with the angle in between. Now, when you're given the 3 sides, side, 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 or 2 angles with the included side, angle, side, none of the ratios will work in the law of sines. You cannot make them work. This one you have no angle at all, and this one you have the angle in between the 2 sides, but you don't have any angle opposite the 2 sides and no way to calculate. So law of sines just will not work. So you can use here law of cosines. Now, they don't explain how they get it. They just say, here it is, which is really good. But what does this one look like a lot? That looks exactly like the Pythagorean theorem, but you have an adjustment to it. Okay? In fact, all 3 of them look like that. Okay? Here's how they go. If you have angle A in between side B and C, notice everything on this side is, on the right-hand side, are B, C, and the angle A. So this is the angle side, side, angle, side form. This is how you get that 3rd side that you didn't know. A squared would be B squared plus C squared minus 2BC cosine A. Okay? Or if you knew sides A and C and the angle B in between them, B squared would be A squared plus C squared minus 2AC cosine B. Or if you knew sides A and B and the angle C in between them, C squared would be A squared plus C squared minus 2AB cosine C. That's what they call the cosine formula. All cosine, sorry. But on the other hand, if you know all 3 sides, okay, you can use any one of these 3. Well, I say any one. Use the biggest angle. Okay? Always go for the biggest angle first. Okay? They haven't told you that, but it will. So cosine of A would be, you get it by just rearranging this. Okay? Add this to the other side and subtract A squared from this side. And then divide by 2BC. And that will give it to you. Cosine A is b squared plus c squared minus a squared over 2bc. Cosine B would be a squared plus c squared minus b squared over 2ac. And cosine C would be a squared plus b squared minus c squared over 2ab. Whichever one of them works. They don't tell you which one to use, but the first example does. Okay? Find the three angles of this triangle. So they give you side, side, side. Okay? Here's the deal, folks. When you give you the three sides, you know which one of these angles has to be the biggest, right? Okay. Now, the way they've drawn this, this appears to be an obtuse angle. Okay? If it is, then you've got to use find the cosine of that biggest angle first. Because an obtuse angle, its cosine is always going to be negative. Right? So when you do the math here, you're going to have, if this comes up negative, you know that's an obtuse angle. An obtuse angle there. If it comes up positive, it's the largest angle, the angle opposite the biggest side. If it comes up positive, you're fine. But if it comes up negative, you know it's obtuse. So you have to figure from there. Okay? So that's why you always go for the biggest angle. Because if you're given three sides, the angle opposite the longest side has got to be the biggest angle. So which one of the formulas would you use? Let me get my pen set up. Which one? Cosine B is equal to the two things you don't have there. A squared. The other one that's not B. C squared. Those two are added. Then subtract the B squared and then divide by 2AC, the two that were the same. So you see, this is how I remember it. You don't have to do it this way. If this is the B, that's going to be a minus B squared. That's only where the B is going to show up. All the rest of them are added and multiplied. Okay? Added and numerated, multiplied. Remember the two. Okay, so take the numbers we know and plug them in. That would be 64. That's A squared plus C squared. I'm just going to put 14 squared. I think it's 196, but I'm not sure. And then divided by B squared. I don't know that one, so minus B squared, which is 19 squared. That's so ugly. Okay. And divide that by 8 times 14, or 112,224. I'm doing that in my head, so I may have it wrong. Let's see, let's do it this way. 28 by 8. I think that's right. Do the math. See what you get. I'm guessing you come up with a negative number. That 19 squared is greater than 64 plus 14 squared. I think the 14 squared is 196, but I'm not sure. Okay, and do that division. Okay, okay, whatever it is, then do that's the cosine of B, then do an inverse cosine and see what you get. guarantee it's going to be the wrong answer. 63.19. Is that what you said? 63.19. Okay, does that look like a 63? That B up there? No. Okay, because what this is doing, you remember inverse cosine it doesn't include any negative angles, okay, or any obtuse angles. It's all between 0 and pi, okay? So obviously that was greater than pi. So what do you do to determine what angle that really is? Okay, let's do this again. That's 63 point blah, blah, blah. How in the world did it ever give you that anyway?
Yeah, I think I did it.
I think you did, yeah. I think something is not right there. It should give you a negative angle, shouldn't it? Okay. What does it give you?
I got 116.8. I forgot to put in the negative.
Oh, okay. Okay, it did give you the right angle. 116.8, which let's just call that 117 degrees. So there's your B, 117 degrees. Yeah, I thought it should give you the right answer. Okay, and it did. Because you see, you're always going to get a positive angle with it. Okay, and that's going to give you 117 degrees. Okay, but where do you go from here? That only gives you one angle. You think you're going to use the law of cosines 2 more times? You could. I wouldn't. Where would you go from here? See there, you have squaring, you have division, you have multiplication, you have inverse, you have lots of things to do on those, right? Much easier to do.
So you can go to the law of sine.
Now do the law of sine. So I would leave that whole whatever angle you had up there and then do that one. And how would the law of sines go here? 19 over the sine of whatever you had. I'll just put 117 or 116.8, whatever you want to call it, is equal to which one you want to go for. Okay, 14 over the sine C. Okay, so sine C would equal 14 times the sine of 117 or whatever you had there over 19. Obviously going to be a smaller angle. I mean, yeah, smaller, yeah. That's the 19 out of 17. Goodness, are we running out of time already? Or are people just getting up? Yeah. Okay, do it quickly. What you get? Anybody? Want to pick up and go on this next time? Okay. What you get? Point six. 657. Then do an inverse sine of that, and what do you get?
41.5. 41.12.
Okay, we'll just say about 41 degrees. Now, want to do law of cosines to get the angle A, or law of sines to get angle A, or what?
Law of sine.
No. Way too much work. Yeah, just add the two together and get, 41 plus 117 would be 158. Subtract that from 180, and I think you get 22 or something like that, don't you? I'm doing it in my head, so I may have it wrong. Yeah, about 22 degrees. Good deal.
I think I found the problem from the book.
Oh, okay.
See ya.
Take care. All right. Just for telling people who aren't here, we'll start next time. Well, we'll go over this one quickly. So we won't do the math on it, but we will show what we got here. So we'll just show example 1, because we've already done it. And then that's where we'll start. So what did you find?
It's 48, and the exercises were 4.5.
Okay, say that one more time.
And 4.5 exercises is number 48.
4.5 exercise. Number 8?
48.
48. Got it. Okay. So let me just clear all this off. Going blank on how to do that. You already saw the ink. Okay. Now let's do that one right under here. Page 304. Oh, it doesn't have. It's 4.5 exercise number 48. Is that what you said? Yeah. And let me write it down, and we'll make sure we're on the same page. We're sketching, graph, blah, blah, blah. Okay. What we have is y is equal to 2 sine of 3x plus 5. Is that what you have?
Yeah.
Okay. All right. Now, where do we begin? How do we begin?
On the A.
So little a is equal to 2. What does that imply?
Absolute value of
Yep.
amplitude.
So amplitude is 2. Okay, next.
B is 3.
B is 3, and what does that lead to?
Period. 2 pi over b.
The period is 2 pi over 3. So 2/3 pi. Now, that I then take to give me the interval, which would be with you in a minute. You can get the trig if you want to. That would be a quarter of that, which would be pi 6, isn't it? Divide that by 4, and 2 will go into 4 twice. That would be pi over 6. Right? Okay, that's going to be our interval. Period is 2/3 pi. Okay, and then our good old, actually this probably isn't what you're looking for. That's not in parentheses there. This is a vertical shift of 5. Is that what you wanted? You wanted a phase shift?
I was trying to get the phase shift.
Okay, would that be something like 44 or 52? 52 has all of them in it. Or 51 has just a phase shift. Or 41, which has a phase shift.
So I'm trying to find one that has, where it's just a whole number, as if like the phase shift is just a number, not like a pi fraction or anything.
Okay.
Because the question on test was like sine of x over 3 minus 4. Minus
Okay.
2. It was the first problem.
Okay. Always make the first problem real hard to discourage people, right? I didn't do it. That's how it came. Yeah. That's not helpful. Here we go. No. The first problem?
Yeah.
That's exactly like this. That's not a phase shift. That is a vertical shift.
Oh, okay.
See, the phase shift has to be inside the parentheses. That is actually a vertical shift. That is just like this one.
Okay.
So you just,
Yeah, I remember how to do vertical shift.
yeah. I didn't think I asked you one that was that awful. Okay. I meant to, but I forgot to. No. Okay. That okay then?
Yeah, that's fine.
Okay.
That's whenever you just, where you take, it's like you're moving the axis up.
Yeah,
to the right.
exactly. Now, okay. Does that mean that's as far as you got on test 2 was just problem 1?
No.
Oh, good. Okay. I was hoping that
Yeah, I
wasn't.
just gotta finish the graph.
Okay, all right. I figured you were further along than that, but then on the other hand, it could happen. Okay. So we didn't do any more on that. That would have been the same type problem. All it is a vertical shift up 5. Yeah. Just don't say yours. Okay. All right. Good deal.
Thank you.
Uh-huh. So let's clear that. Get out of there. Oh, I forgot to tell them what homework exercises to do. But they can live without it. We just finished another section. Okay. And I forgot to do this.